Let's try and understand effect of temperature on solubility. So for example, if we take potassium nitrate, we find that potassium nitrate solubility keeps on increasing drastically with temperature, alright, KNO3. Whereas in case of KCl, we find there's slight increase in solubility with temperature. Similarly, in case of NaCl, also we find slight increase in solubility with temperature. So it is very difficult to separate sodium chloride from potassium chloride at any temperature. Then another interesting fact is sodium sulfate, the solubility of sodium sulfate keeps on decreasing with increase in temperature. So whenever such differences in solubilities occur with temperature, it becomes very easy to separate those salts at higher temperature. So this is how the use of temperature and solubility can be applied for separating one salt from other. So we can conclude from this graph that developing a relationship with temperature and solubility is a bit difficult. Why? Because in case of KNO3, we found that along with temperature, solubility increased. In case of sodium chloride, potassium chloride, we found there was no drastic change in solubility with temperature. Whereas in case of sodium sulfate, the solubility in fact decreased with rising temperature. So what do we say about gas, solubility of gases with temperature? In case of gases, yes, we can develop a relationship. Now for this, let's take example of water bodies during summer. Now in water bodies like lakes, stream, rivers, ocean, sea, whatever, we find during summer all the aquatic animals move towards the base or the lower part of the water bodies. Why so? Owing to high temperature, dissolved oxygen evaporates from the upper portion of water bodies, creating oxygen deficiency, into which all the aquatic animals have to move in towards the lower portion. So this itself is a direct relationship of temperature with solubility of gas and water. With increase in temperature, solubility of gases decreases. Alright.